We also have devices which low level research. We're actually working on that. And it will probably take 5 years for them to become commercially available. Definitely would like to see it. It's also going to be complex and actually
Please take your seats. Please take your seats. Hey, people. I'm glad to see there's so much enthusiasm for privacy preserving measurement. Thanks to everyone. Thanks to everyone for coming, and congratulations on making it through the first day of IETF 117. Do we have a minute taker? I'm not aware that we have a minute taker who's volunteered. As you know, we can't start the meeting without one. So if you could take some minutes for us, that would be really helpful. Minute taking has gotten even easier than ever before thanks to our automatic transcription. There's really no need to try to write down everything everybody says. Just the minute taker's responsibility is only to note important points or decisions that aren't otherwise captured. I'm going to proceed with the chair slides and hope that somebody volunteers to take some minutes for us for privacy preserving measurement. So, as a reminder, participating in any IETF working group meeting like this one causes you to incur certain legal obligations. You should really understand what those obligations are. This slide documents some of them. If you're not familiar with all of them, please take the time to read it and make sure that you are able to participate here. In addition to the legal obligations that you incur, there are also some other obligations that apply when you participate in an IETF meeting related to your behavior and our standards of behavior. So please make sure to maintain civil and professional discourse in IETF spaces. Just a technical reminder, somewhere in this room there should be a clipboard. It's right here. So I'm going to walk this around the room just to make sure that everybody remembers, or Sam will do it. Thank you. So please pass this clipboard around and use it if you haven't already connected to the on-site tool. Otherwise, they'll squeeze us all into a tiny room next time because they won't think that anybody can. I believe that's the same QR code. So any way that you, as long as you connect to the on-site tool, or however you do it, that's sufficient to make sure you're registered in what used to be called the blue sheets. Here is our announced agenda for this meeting. If anybody has concerns or ideas for how we could improve this agenda, this is your chance to tell us about them. Otherwise, we'll charge ahead with this agenda. Would anybody like to revise this agenda? Remember, we only have 60 minutes, so we will be trying to keep everybody on time for these time slots. Okay, hearing no revisions, we'll be able to move ahead, except that we still don't have a minute taker volunteer. So we're not, well, okay, Sam Weiler has volunteered as minute taker. This is a little bit unusual, but I think we're going to charge ahead given the tight timeline. So, Tim, maybe you could tell me how to pronounce your name so that I will know going forward.
It's Gagan. You just ignore the first syllable and then go for it.
Okay, thank you. Tim Gagan, would you like to share any slides with us?
I believe they're already there. Could I ask you please to drive them for me?
Sure.
Thank you. So as our chairs reminded us, we do have a tight session today. So for this deck in particular, I'm going to try to zip through it so we can get to the more interesting new stuff. So what I want to cover here is just updates on draft changes since last time and some implementation news. Next slide, please. Okay, so we have some new draft versions here in the PPM working group, which is to say we have revision 05 of DAP, and that goes hand in hand with VDAF, Verifiable Distributed Aggregation Functions. Draft 6 of that was published in CFRG, I think shortly before this meeting. So the headline change in DAP 05 is what we're calling the ping pong topology. What this means is that DAP is now specialized to always exactly 2 aggregators, 1 leader and 1 helper. Previously, there was sort of an attempt at supporting arbitrarily many helpers. In practice, like all the implementations, handled exactly 1, and we were really struggling to figure out like why deployments would want more, given that there's a sort of a conceivable privacy improvement by adding helpers, but there's a huge increase in the cost of running the protocol and availability risks. More to the point, specializing to exactly 2 aggregators brings us some meaningful simplifications to both the protocol and implementations. And the really nice thing is that it enables this performance improvement. This is the ping pong stuff, where now instead of like the leader broadcasting out prepare messages and then gathering back the the prep shares from all the helpers, the leader and helper now take turns combining prep shares into prep messages, evaluating proofs, and then telling each other whether inputs are valid. So concretely, in the case of the Prio 3 family of VDAFs, this allows us to cut the number of round trips, HTTP round trips that is, between leader and helper in half. So there was much discussion of this back at IETF117. The slides of that deck are linked here. There's also a ton of discussion in the pull request where this change was made up on GitHub, if you're interested in more of the context and the details, as well as some thorough characterization of the performance win. So although DAP now is exactly 2 aggregators, VDAF still supports arbitrarily many aggregators, which leaves the door open for like other protocols built on top of VDAF to use different sorts of topologies. Also, we are open to better names than ping pong for this because we think it's like a little silly, and that's why we keep putting it in air quotes everywhere. Okay, and then on the VDAF side, the big change there again is there's some extra interfaces like wrappers around the existing VDAF methods that support the ping pong stuff. And there's an interesting change to Prio 3 histogram, which is now parameterized by the number of buckets in the histogram rather than the boundaries of the buckets. So this is a way more efficient representation, given that like some applications of the Prio 3 histogram are vectors which can have hundreds and even sometimes thousands of dimensions. So now the representation of the histogram is like a single integer rather than this huge vector. Okay, next slide, please. As for implementations, so we have the same set of implementations as previously. libPrioRS is our Rust implementation of the VDAF layer. VDAF 06 is fully implemented there in the 0.13 series of crates. And as we said the last couple of times, we still would really love to see more implementations of VDAF. We have a couple of DAP implementations, but more diversity for VDAFs would be great. Also, like languages besides Rust would be cool. We'd love to see a Go implementation. Further, there's Daphne, which is a helper implementation, runs on Cloudflare workers. Its DAP 05 implementation is in flight. Giannis implements all of the roles of the DAP protocol, and we have a prototype implementation of the ping pong stuff, which we use to prove out like the protocol changes. We have to do a bunch of cleanup on that to like line it up with what ultimately landed in DAP 05, and we're hopeful that we'll merge that in the coming weeks. DivvyUpTS is a TypeScript implementation of a DAP client. We have a complete DAPO4 implementation, though only for Prio 3, and we should only need minor changes, namely updates to like domain separation strings to get to DAPO5 and VDAPO6. And finally, Firefox is working on integrating a DAPO5 client. I think they have a DAPO4 one. They again just need to make tweaks like domain separation strings. Next slide, please. Okay, and as for stuff that's coming up in the future drafts. So one thing we want to look at is server differential privacy. Although, as it turns out, possibly this work will also include local or client differential privacy. You're going to hear more about this like right after this deck. We also want to invest some time in overhauling the security considerations, which are a bit sprawling and out of date at this point. And I still am interested in trimming the error codes, the list of error codes and error handling in general down to the bare essentials. And eventually, as we accumulate more operational experience, we expect that there will be some changes to make Poplar 1 more scalable. And I think that's it.
Thank you. Are there any brief questions? If not, and even if there are, Chris Patton, I think you are up. So I'm going to use the app before. Did I do it right? Looks good to me.
Oh, sweet. That's so cool. Technology is really advancing. All right, everybody. So this is a topic that has been on the tip of our tongues. Like, I think we even talked about this at the second PPM meeting back in the day. We started, a few of us have been like actually working on what does differential privacy look like for DAP. So I wanted to kind of show you where we are. And we have a proposal, and we have some questions about scope and where should it go. I'm eager for your all's feedback. So just a quick overview, differential privacy, what is this thing? A lot of people have heard of it. How does it apply to DAP? So what DAP is doing is taking some measurements and aggregating them. And we have this thing, the output we call the aggregate results. This is like the mean or the standard deviation, some summary statistic over your set of measurements. And protecting the measurements themselves, that's all DAP is really good for. It's not necessarily sufficient because the aggregate result itself might leak sensitive information about an individual measurement. Kind of a simple, dumb example is, let's say you're taking the average of a bunch of people's heights. If you include in your sample population a particularly tall person, the average might end up leaking bits of that person's height, that information we consider sensitive. So differential privacy would be, it's this property of the aggregate result, or more generally, the view of the adversary who is watching this protocol execute and maybe even taking part in the execution. DP of the adversary's view means that this view should not change significantly if one of the measurements is replaced by another. So simple enough, basically no single measurement should influence the output too much, for some definition of too much. That's the hard part, by the way. And basically the way we solve this is by adding noise. So clients can add noise to their measurements. Aggregators can add noise to the aggregate shares. The collector could just add noise to the aggregate results. And basically the combination of things you do here, there's many combinations, will determine kind of the security you get in what threat model. So it's simple enough in principle, just add noise. But there's a lot of complicated things that go into this. The first one is the mechanisms by which we provide differential privacy. Basically, we have to be able to sample values from some concrete distribution that gives us a particular property. These turn out to be very hard to implement correctly. There's lots of different bugs that can come up if you do things the wrong way. And there's also side channel considerations. Basically, the time it takes to generate noise might leak the value of that noise. Another consideration is that choosing the optimal DP mechanism or policy is kind of depends on the VDAF and also your application. So there might be multiple choices that make sense. Yeah. And then there are also like higher level protocol details that impact what level of differential privacy you can actually prove for your protocol. So in DAP, we have like some metadata that comes up, and that limits kind of the notion of privacy we can achieve. I wrote intersection attacks here because that comes up in general. It doesn't really come up in DAP in particular because we have a mechanism for preventing this. So, and then lastly, the last point is that the differential privacy literature doesn't provide a lot of, well, I mean, there's a ton of work on tuning the privacy parameters for a particular application, but this process is as far as I can tell, requires a lot of domain expertise. And this is like kind of the trickiest thing. Basically, the more noise you add, the more privacy you get. But by adding noise, you're reducing utility of the system because you're not getting the result. You're getting some the result plus some noise. So the proposal here is we started working on a draft. The plan will be to write this draft and then recommend changes for the DAP and VDAF drafts as we need to. The status is that we're in very early stages. We missed the draft deadline. We wanted to share it with you all today, but didn't make it in time. But there's a lot to shape here. We're looking for contributors. So if anyone is interested or has expertise in this area, please let us know. And the questions I want to try to tackle are basically, we don't know where this goes yet. Which working group? Is it PPM or is it someone else? And then I'd like to discuss the scope of the actual document itself. So let's start there. What we're proposing is kind of like 4 basic components. One would be like an overview of the, Martin, can I go through this slide or do you want to?
I was just going to say, I think you probably want to answer the question on the last slide first before you start diving into the details.
Okay. I would say that if we scope it to DAP and VDAF, then it's a slightly different. Well, okay, sure.
Right. It's true, but I think it is going to be scoped to DAP and VDAF, and necessarily so because of the nature of the previous points that you made. And I think we don't deliver on the first P in our charter if we don't have something along these lines available to us at least.
Yeah, I agree with that.
There may be some cases where you can rely on some combination of local or shuffle DP in order to get the sort of guarantees that you're looking for, but this is probably one of the most important pieces to my mind of the protocol that we'd be building here. So I'd like to see us do the work even if not everyone's using it.
So yeah, just to be very clear, among these options, you would say PPM could adopt it. Okay. Martin has thumbs it up in the affirmative for the record.
So I'm not sure where we are now in terms of like what the discussion's about, because it seems like Martin actually we went directly to like what work should happen.
I'm happy to go back to where I was, and I can tell you what we're proposing.
Sure.
So I think what we want to initially is a brief overview of the DP literature. I have noticed that there's lots of different variants. There's lots of ways of refining the notion of differential privacy, and not all of them are going to apply to DAP or VDAFs. And I'd like to, I'd like to see something like a literature review. I don't know how that fits into a draft, but I think we can, I think we need more information. So there are some limiting factors. So for example, there's this notion of remove or substitution DP, technically slightly different definitions, and only one applies to DAP because we leak the number of reports in the batch to everyone involved. There's also metadata. So the timestamp, the report timestamp is a limiting factor. Also, the client IP can be a limiting factor. So, if you had an OHTTP proxy in front of DAP, you might be able to prove something stronger. The other thing, the main meat of the draft is going to be the mechanisms. So the tools that we need to actually sample from a given distribution. So folks might have heard of discrete Gaussian or discrete Laplace. These algorithms are complicated and easy to get wrong. So I think there should be a standard for these algorithms. And then lastly, what we're calling DP policy right now. This is basically compose a VDAF with a concrete scheme for differential privacy, and so that everyone could reuse the same scheme. So there's kind of like standard approaches to applying DP mechanisms to VDAFs. And then finally, we would describe the concrete DAP integration, which depending on how far we want to go can be might just be very straightforward. I would say there are things I maybe should be out of, like, off the bat. I'm not sure that we can say much concretely about privacy parameter tuning. So things like how do you pick the right epsilon and delta for your distribution? I'm not sure anyone is there seems to be so much domain expertise required to answer this question. I could be wrong, but if it ends up being very application specific, I'm not sure how useful it would be to get into details in the draft. And then there are also more sophisticated DP mechanisms than the ones we're looking at right now. These can be considered. And then I'm not sure we want to be more general than VDAF and DAP. So as far as DAP integration goes, you basically have some simple API calls at various stages. The client will add noise, the aggregator might add noise, and then for local DP mechanisms where the clients add noise, there's this you have to kind of remove the bias from the aggregate result. So yeah, that's it. Go ahead. Echo.
Yeah, so a few points. I don't want to make the best be the enemy of the good.
Mm-hmm.
And this working group is not chartered to do this work. So I think it's fine to have it happen, but the way you're just talking about it scares the hell out of me. So certainly this should not be on the critical path item for publishing DAP. So that's the first thing I would say. Second thing is, I guess I don't really understand the framework in which client provided DP fits into the threat model for the system. Namely, like, the reason the client provided DP is because you don't trust aggregators, and we already have existing experience with client provided DP in systems like Apple's. The performance is abysmal or poor, and so I guess I don't really understand, like, the epsilon tuning you need to have a situation where you don't trust aggregators is quite ungood for, like, actually getting results that are good. And so I guess I don't understand how you would think about how you'd reason about that problem.
Yeah, I think I agree with you. So the way I think about local DP is it's this property that you get if everything falls apart. It's kind of like hedging. So if you lose trust in both aggregators, then you have at least local DP, which is not nothing. It's not perfect.
Sure, I understand, but my point is, why bother with DAP then?
Yeah, I mean,
I guess my point is, like, the nominal premise you would think would be that you could, like, use maybe a less aggressive epsilon, a less conservative epsilon, I'm going to put it, because you also believed in DAP, and I don't know how to reason about that.
Well, so I don't think local DP is a replacement for DAP. I think that because central DP is better than local DP as far as I understand.
In terms of cost effectiveness.
In terms of just privacy.
Well, I mean, assuming you trust the central thing.
Yes.
I mean, the premise of central DP and local DP are different threat models, right?
We have 5 people in the queue and 2 minutes on the clock. So please try to be brief.
So Echo was talking about one aspect of the threat model. I want to talk about another aspect of the threat model. Assuming, of course, that we're doing central DP, there is the possibility that we could simply have each one of the aggregators add noise independently, which is one of the things I think Dwark in 06 or something like that suggested very, very early on in the process. that has implications for our threat model in the case that one of the aggregators is dishonest.
Yeah.
And we need to work through that. There are protocols for adding differential privacy noise to things in MPC. It might add a few rounds to your VDAF, but they exist. That's the sort of thing we're looking at for IPA in particular, and would be worth considering whether or not that fit, which one of those fit into our threat model here. We are pretty keen on the notion of not having the simple method as far as IPA goes, because if you have a defecting aggregator, you're in a situation where half the noise is known, which means or in our case, 2/3 of the noise is known, which is not exactly ideal. So something to think about.
Yeah, I definitely don't want to. I agree. We don't want to like restrict ourselves to one method. Yeah, I agree.
Watson Lad, Akamai. I think that the answer to your question of which working group is here. I think if you went to dispatch, it would kick it right back. And yeah, this is something that we might have to recharter down the line. It shouldn't be a longer thing, but this is clearly the right place to discuss it.
Thanks.
Tim Gagan, ISRG. I guess to echo Watson there, yeah, like certainly there's concrete mechanical bits of how DP concretely would work in a VDAF and DAP that belong here. It does seem like there's other elements of guidance that possibly belong elsewhere. But in any case, sorry, what I came up to the mic to say was more on the topic of local differential privacy. I've long felt that like DAP should say nothing about this, which is not to say that people shouldn't use it, but my opinion is that, in fact, my experience from having deployed PRIO or for the exposure notification system is that local DP can be applied orthogonally to PRIO. And so from like a minimalism point of view, and like on the premise that the less protocol text we write, the less likely we are to screw it up, I prefer to not say anything about it. Which like
Yeah. So the composition of different DP mechanisms into what we're calling right now a DP policy needs to be thought out very carefully. And there's a lot of ways to kind of do this. I definitely, as far as DAP integration goes, perhaps we don't have to say anything, which that would be perfect. I think the meat of this document is probably going to be the specs of the algorithms themselves. And then we can kind of say like, this is how you, this is how you compose them with a VDAP to get something that has this DP privacy guarantee, which is, so it's the point. The point is basically we're trying to enable people to use DP with DAP. That's the essential problem to solve, because we need this feature.
Yeah. And for Christmas and for the record, like I do think we ought to spell out explicit things for server DP. Although I'm concerned that we won't be able to say very much of use about choosing epsilons and deltas, but that's just a very, very hard problem.
Hey, it's Shan here from Apple. Am I in the queue? I think so. I just want to quickly answer the question about local DP and why do we need it. I think Eric was right. Local DP alone is not very useful. It's going to have very poor utility. But local DP coupled with the aggregation amplification, I think we have a chance to have a pretty decent utility compared with the aggregator DP, where you have to add twice the noise on both of the aggregators because you can't trust both of them being honest. And for that reason, we also need to mention it in DAP because there is a chance if we have not enough local DP added into a batch or into an aggregation, there could be an opportunity for us to add a little bit of aggregator DP just to make up of the local DP that's missing from the collected batch. In that case, we have to say something about adding this kind of aggregator DP because the local DP has already been added. This has been written in the draft in the GitHub repo. I think we can talk about details over there. Thanks.
Okay, thank you, Sean. Tim Gagan, it's your microphone.
I'm going to give this phone tool a spin. Can I use this to drive slides, but I've already been... Ooh. Okay, I'm not sure what's going on now.
Chris, I believe we're still seeing your slides. Okay.
Meet Echo is haunted by the ghosts of dead slide decks.
Okay. Let's try that one more time.
All right. Share. Okay, cool. And I can even go back and forth. All right, sweet. All right, so I want to talk about the query modes in DAP. So to be clear, like I don't want to come out of this particular conversation with a decision because this is actually the first time that this question, this topic has been broached in the working group, right? So it's premature to make decisions. What I want to do here is stimulate discussion and particularly flush out people who strongly disagree with what I am proposing to do, which is why I'm presenting here. But first, let's do a little background. So what's a query type, right? All right, DAP today has a notion of a query type. Like a task, when it's defined amongst aggregators, must choose one of these. There are two that we have currently. The first is time interval, which is sort of intuitively the more obvious way to do things. The collector, when it's getting aggregates, will tell the aggregators, hey, I want you to aggregate over the reports whose timestamps are in some time interval, this hour, this day, what have you. The result is that the batch identifier is that interval of time. And incidentally, one of the nice properties of this is that either aggregator can independently verify whether or not a report actually belongs in a batch because either aggregator can see the timestamps in the reports. The other query type, which was introduced more recently, I believe in DAP02, is fixed size. So in this mode, when you define the task, the collector or subscriber will indicate sort of a desired batch size. So for instance, you might say you want to emit an aggregate over every 1,000 reports that get processed by the aggregators. Resultingly, the batch identifier is just like a numeric ID that gets assigned by the leader. I believe they're increasing monotonically, but I forget if that's actually a strict requirement. So, batch ID 1 would be first 1,000 reports, batch ID 2 is the next 1,000, and so on. The leader in this setting has the power to assign reports to batches however it pleases. The protocol doesn't say what the leader should do. And as a consequence, the helper doesn't have any ability to independently verify whether a batch, whether a report belongs in a batch or not. And further, you might also have two batches that cover overlapping time intervals, right? So in either case, though, the representation of an aggregate that gets delivered to the collector by the aggregators includes the time interval that's spanned by the constituent reports. So even in the fixed size case, the collector still gets to know that, these 1,000 reports, their timestamps were between 11 a.m. and 12 p.m. on Monday, the whatever. Okay. Oh dear. Oh no. Sorry, I lost the forward back buttons. Yeesh. Okay, don't let your phone lock while you're presenting. Okay, next thing to recap is DAP anti-replay. So what we care about here is we don't want to do something pathological like emit an aggregation over a single report because that would trivially violate the privacy of that contribution. So what DAP does about this is it has a notion of a minimum batch size and aggregators will refuse to emit aggregates if there are too few reports included. Now, where this gets more complicated is there are some, so in the case of PRIO, right, a given batch only gets aggregated one time. But there's some other VDAPs, concretely Poplar 1, where the same batch can be aggregated multiple times with different aggregation parameter. Concretely in Poplar 1, what this means is you're using successively longer sets of string prefixes, trying to drill down to the top 10 most popular strings in the aggregated set. So so DAP requires in that setting that the batch membership not change across queries because you don't want to allow something like aggregate over 1,000 reports, then do a second aggregation over 1,001 reports because you could probably learn something about the one report that occurs in the second aggregation, but not the first. So what this means is that the first time that aggregators service a collection request or an aggregate share request, depending on which aggregator we're talking about, they have to permanently commit to the set of reports that are included in a batch. Now, in the time interval setting, this leads to a problem with reports getting orphaned, which is illustrated here. Excuse me. So suppose you have like a bunch of clients and they're all doing uploads to the DAP leader. You have a whole bunch of, illustrated here on the right, you have a whole bunch of uploads going on with say timestamps 1, 2, 3. But then, the report of timestamp 4, for some reason, the upload doesn't make it. It gets, a router fails somewhere, it just doesn't make it to the leader. Then the collector happens to issue a collection request over the time interval 0 to 10. The leader, let's suppose that this satisfies the min batch size. The leader and the aggregator, the leader and the helper will dutifully service that collection request and emit an aggregate over the reports of timestamps 1, 2, 3 and deliver an aggregate result. Then later, let's say a client retries and finally that report of timestamp 4 gets delivered. That report can never get aggregated because it arrived too late and the relevant time interval has already been collected. Further, there's no upper bound on the number of orphaned reports in this setting, right? Because any report whose timestamp falls in the collected time interval that arrives after the collection request gets serviced can never be aggregated, and that could be a very long tail, depending on the setting. Imagine just a spotty network connection or an application that doesn't get to run all the time and so has to defer when it does uploads to save the next time a user happens to launch it. And there's really no good way for the collector to know what's a good time to issue a collection request. All it can do is rely on these sort of messy heuristics of well, if I'm aggregating over a 6-hour window and maybe I should wait a full day before I try to collect because maybe that's enough time. But this is sort of an unsatisfying way to weigh these trade-offs, in my opinion. Now, on the fixed size case, it's a different scenario, right? So, suppose you have a similar thing, right, where you have a whole bunch of uploads coming and one of them doesn't make it until it gets retried later. There's no harm if the collector makes its collection request sort of too soon, because the leader is free to take those late arrival reports and just stick them in the next batch. As we discussed before, it's perfectly all right in the fixed size setting for 2 or more batches to have overlapping time intervals or indeed the same time interval. As we discussed, the collector does still get to know what was the interval of time spanned by the constituent reports. Now, there is still a possibility of reports getting orphaned because suppose that the number of late arrivals is lower than min batch size. But at least now, the number of orphaned, there's a clear upper bound on the number of orphaned reports, which is the minimum batch size. And that's a parameter that is not always, but often going to be controlled by the collector because in a lot of settings, it's the collector that is provisioning tasks into the aggregators. Okay, what's next? All right, so this is the question I've been laboriously making my way toward, which is fixed size kind of just plain better than time interval? Given the unbounded data loss risk, what would lead someone to choose? What would lead a deployment to choose time interval over fixed size? The other thing is, we've been batting around an idea, on the DivvyUp team, about sort of a kind of a variant on a fixed size queries that would still allow you to effectively simulate time interval, right? I mean, imagine you have a population of installs of some application where you know the number of installs, because the App Store tells you, or the number of downloads, something like that, and you have an idea of what, say, the opt-in rate is for the telemetry system that you've deployed. So you can sort of predict how many uploads you expect, right? And then you can tune your batch size when you create your task appropriately, such that you can roughly expect, right, a given number of uploads per hour. And so if you set your min batch size that way, then do fixed size, you'll still get roughly, say, hourly or daily or whatever you want. Go ahead, Ecker.
I have some bad news for you.
I'm listening.
This is an incredibly seasonal situation. This will not even remotely work. You will get some days you'll get an hour, some days you get 30 minutes, some days you get 4 hours. The use intensity of systems like this is incredibly seasonal. So this will not work. Now, maybe you may say, I don't care about fixed time windows, but this is not a replacement for time windowing.
Okay, thanks. With that noted, I guess I'll still go through what we see. Well, no, this is exactly the discussion I wanted to have, so I'm happy to get that observation. So I guess I want to further support the upside of potentially eliminating time interval. So for one thing, I think it would allow us to clean up the semantics of the collection API. Right now, what we have is one collection API that is trying to capture both time interval and the fixed size case. And the tension there is that, at least in my view of it, time interval is kind of like the collector pulling aggregates from the aggregators. It's telling them like, hey, give me an aggregation over these things and give me the result, right? Whereas fixed size, I think it makes more sense to think of it as the aggregators pushing batches into the collectors. And in fact, like a pub sub type model, or a message queue is a very natural fit for this. So the API currently is a little awkward because it's trying to do both. But if we only did the one, then we could have, at least aesthetically, I think, a better API. There's also, go ahead, Martin.
I didn't want to interrupt you halfway through the sentence, but it seems like that's how it works here. Sorry about that. I like the idea of pulling, but this idea of a fixed time interval seems to have those problems that you identified previously. Is there not an option where you can just pull whatever exists in the aggregate right now, with no regard to which reports were included in that batch, rather than aligning on time intervals? So you can pull your hourly report, and then you get whatever came in the last hour, and then on the next hour you pull the report, and then it would fit.
Well, that would sound like time interval. So like, you
It's not time intervals then.
Sorry?
It's not time intervals in the sense that the timestamp in the report determines when it would be collected. It would be essentially variable size batching. You'd still have your minimum threshold so that you don't end up with the problems that we've identified previously, but you would have a situation where the report collector would ask for whatever's happened since the last time I asked. And that would be fine too, right?
So are you suggesting basing this like on the time of, say, arrival of the reports at the aggregators rather than the timestamp that was like the time of generation of the measurement in the clients?
Potentially, yes. Although, yes, that has the same property that your proposal has as well, which is that you don't necessarily know the correspondence between the window of time over which they arrived and the window of time in which they were generated. There's potentially, when there's delays in getting reports into the system, you potentially have reports from a long time ago.
Yeah.
But you've already identified that we have this difficult trade-off already, which is delayed reports either get ignored or included in a later report. And this sort of biases more towards the include in the later report side of things, which is, I think, a decision you're already suggesting.
Yeah, yeah. A concern that comes to mind is you might end up with aggregates that end up like smeared over these sort of difficult to reason about time periods. Like say, if the collector wants like hourly chunks of reports, but they end up with something that's like, oh, here's an aggregate over 100 reports, but it spans like a week. I'm not sure if that's useful.
That's why I was getting to the next point, which is that when you make a query, perhaps you can say, if there are any reports that are older than X, disregard them when you go through the collection process. Now, this is not something that Prio with a running count can necessarily do, but that's potentially something that you could consider doing.
Yeah. Definitely, a point in the possibility space to consider.
I'm wondering how you would handle if you have simultaneous time periods that you want to compare. So like I have some aggregate that I want to compare for 2 branches of an experiment. Like how would you sort of handle that in this case? Like it seems to me like you wouldn't be able to have, exactly the same time period compared for the same.
Well, I think in the first place, those would be 2 different DAP tasks, right? So you'd have, this is like config you push to your client. It's telling, in the first place, it's telling it like do behavior A or B, and then it would be reporting like that it did a thing or not, right? To like a corresponding DAP task so that you could tell one or the other, no?
Sure, but say I want to know exactly over a week, right? So I want to know like in this week, what is my count for this group, and then for the second week or for the same week, I have 2 groups that I want the exact same time period.
I understand.
Yeah.
So you need to align the time interval. Or,
yes.
Well, sorry, time interval is ambiguous here, but I think I understand. You might have 2 different tasks and you want to make sure that you're aggregating over the same span of time to both.
Yes. And then also in addition to that, I think this seasonality question is also important for like basically any experiment we're going to run. We want to know, there's a lot of seasonal fluctuation over the day or over the week. So that's like definitely a use case anyways. So yeah.
Okay. Thanks.
So, Chris Patton, Cloudflare. Just to remind folks, kind of the intention of query types is that there might be lots of ways you want to split up data. Like all of these questions are coming up. These are all kind of like different ways of slicing data. And the idea is that we would constrain them inbound in the protocol. So the idea is that what we're trying to do with query types is support different use cases where you have different relationships between the entities. So in particular, the collector has some control over the data. I want to know, and in an interoperable manner, right? So, okay, my point is I support this idea because it's reducing complexity in the protocol.
Oh, somebody likes it.
What we're giving up is the collector having control over how things are partitioned. But if no one here has a reason to have this semantics in the protocol, then let's get rid of it. So far, like our use cases that I've seen, we don't actually need it.
My opinion is that the seasonality argument that Ecker raised and Kate echoed is currently sufficient to sort of torpedo this. But my takeaway is probably we need to work harder. And I mean, the Divvy Up team, for instance, think harder about whether we can do anything about that seasonality question. Sorry, Ecker, go ahead.
Yeah, I wanted to make 2 points about your pure problem statement here. The first is that I think that the orphaned request problem there comes in, I think, 2 flavors, right? Yes, orphan requests first, which is many systems, Firefox included, do not in fact trigger their aggregation on the timestamp in the message, but on the arrival time, and this works, and so there's no overlapping window problem in that case because things simply arrive when they arrive, and you just live with the fact that the timestamps are varied, right? And so you may think that's a bad practice, but it's a common practice. The second thing I would say is this sort of this concern that you seem to have about having min batch size, not being able to estimate min batch size, and having having to sort of expand your contractor window to match up with the batch size. That's a problem that people actually have only when really they have a very small user base. Because when you have a user base in the millions, then min batch size is quite small compared to the number of messages you're going to get. And you simply have to set the size of your experiment or your sample to have a very high probability that you will achieve min batch size within the time window. And that's a much easier seasonality problem because you only need to estimate the minimum number rather than trying to estimate it precisely. And so if the min batch size is say 1,000 or 5,000, then all you have to do is have statistical power large enough to have a very high probability of having 5,000. So I guess I understand that it seems to me that when you sort of take those factors into account, really you're kind of left with this complexity argument, which is not of no value. But I think DAP is already quite complicated, and if we want to do, and if we don't want it to be not useful, we can do nothing. So so the question really is it useful?
Thanks. Yeah. So I think my takeaways here are think harder about what can we do about seasonality and how bad really is this orphan report problem in light of what Ecker just highlighted. Thanks. I very much appreciate all the feedback.
I just wanted to ask the chairs if we might have an interim on this topic.
I don't think we're going to make a call on that in this moment, but okay. Thank you for raising the topic.
I think it would be incumbent on me and my teammates to do more work and post something interesting, say, to the mailing list, right? More findings, more suggestions before we go, and then once that happens, maybe an interim makes sense. Okay, I'm going to be quiet so we can do the next thing.
Okay, our last speaker is Christian Priebe of Apple. I assume you are remote. Would you like us to run slides, or would you like to request slides? Christian Priebe, if you're listening, I see you in the participant list, but you haven't requested audio or video. So we don't see you. Christian has left the participant list. I assume he's rebooting his connection.
Can you hear me?
Yes.
I'm actually not supposed to present. Lin Mao, who should also be on the call. Oh, Lin Mao. He's going to present.
Okay. Thanks for the correction.
Lin Mao, are you there?
Yeah.
Okay.
Hi,
Thanks.
everyone. Yeah. Hi, everyone. My name is Lin Mao. I'm going to present a proposal for the DAP extension, co-authored by Christian Priby and myself. So the extension is about report authentication. And what problems are we trying to solve here? Well, the main motivation is cyber attacks. Currently, the DAP protocol does not provide a mechanism to prevent a malicious party from generating a large number of reports. So what are the potential impacts? There could be privacy violations, and there also could be statistics poisoning. So the dilemma here is that to effectively counter for this attack, and we often need a read limiting, which very often needs strict authentication. But obviously, we cannot do that on the aggregators. And how do we propose to solve this dilemma? Well, we propose that by leveraging the so-called privacy pass protocol, which is another IETF draft, there is a way for the aggregators to verify the reports have been authenticated and optionally rate limited without learning the client's identities. So here is how the protocol, the extension works. It can be divided into two parts of the communication can be divided into two parts. The first part is essentially making the client allocate a privacy pass token, and as more or less as per the standard protocol. So if you are familiar with the privacy pass insurance protocol, you see familiar message flows and also entities like attester and issuer. So we'll come back to this part later. But the second part of the communication is essentially making the client attach the tokens to the DAP reports and making the leader and helpers to validate the tokens as part of their initialization. And so here is the structure of the extension and also its location on the inside DAP report. So on the diagram on the lower part of this slide, you see its location inside a DAP report. So this extension sits inside each of the encrypted input share for each aggregators. And the structure of the extension is very simple. We see the extension type and also the token itself, and also the challenge which was used for obtaining the token. So why the challenge here? Well, if you go back to this previous slide, and in the first communication flow, you see there is a slight deviation from the standard privacy pass issuance protocol in the sense that the client is synthesizing the challenge instead of making the challenge coming from the leader and the helper. And why is this deviation? Well, if we allow the leader and the helper to send a message, to send a challenge to the client, then they have a way to associate the client's identity with a token. And that defeats the purpose of the DAP. So that's why we are here. We are making the client synthesize the challenge, and that's why the challenge has to be placed inside the extension itself, so that the aggregators will be able to validate the token as per the standard privacy pass flow. So if a client wants to support this extension, what changes does it have to make? Well, first it needs to be able to acquire a token as per the standard protocol, apart from the part which synthesizes the challenge on the client side, and as we have just discussed. And also what's important is that the client needs to disassociate the token acquisition from the report creation. That is just to avoid any potential timing attacks. So at the time of the report creation, the client simply picks an unused token, a pre-allocated but unused token per aggregator, and encodes the token and the challenge inside this report extension, as we have just discussed above. That's all for the client. And how about the aggregators? Well, the aggregators need to be able to validate the tokens, and they first extract the token and the challenge from the upload extension, and they validate the original info field of the challenge to make sure that it contains their own host names. This is essentially to prevent the client from, for example, double spending the token across different aggregators. And the aggregators then validate the token as per standard privacy pass authentication scheme. And what's important here is that they need to make sure that the tokens were allocated with still active issuer public key. And the reason is to prevent the client, for example, from accumulating tokens from half a year ago and then spend everything in one go. And the aggregators also needs to keep track of the token norms, basically prevent double spending. And so inside the extension, we also have a few recommendations and optimizations depending on the underlying security consideration and also the trade-offs. So we recommend using the rate-limited variant of the privacy pass issuance protocol, and just because it provides more control over the rate limiting. And we also have a potential optimization depending on this, the trade-offs to leverage the existing DApp, the dedupe mechanism to prevent the token double spending. And another potential optimization is for reducing the potential traffic or load on the privacy pass architecture by conditionally allowing tokens to be reused across tasks. And these are not as finalized yet, and there are still active discussions on the GitHub repository. Here is the location of the extension proposal, and we welcome your feedback and contribution. And thank you very much.
Hi, Eric Scorla. I have a question I think I know the answer to, but I want to make sure we're on the same page. Why can't you just use Privacy Pass directly with the HTTP bindings?
Sorry, could you repeat the question?
Why can't you just use Privacy Pass in the normal way as bound into HTTP rather than attaching to DApp?
So I don't know if you are talking about the this communication part. You mean the I didn't quite get the question. You mean the normal?
What I'm saying is, sure. What I'm saying is we already know how to use Privacy Pass with ordinary HTTP.
Yeah.
So why can't you just use it exactly like that without changing DApp at all?
So the so I guess we deviate a little bit with this challenge synthesizing. I don't know if that's the question. And for the reason is like we previously mentioned, if the challenge is issued by the leader and helper, then it basically associates the token with the client identity, and so that's why we allow we deviated from the standard protocol by making the client synthesize the challenge.
No, but I'm saying
sorry.
What I'm saying
is,
please
go ahead. Go ahead. I mean, I would like to answer your question, and I'm having some technical issues. So I can't see the queue right now, so I'm not sure if I'm allowed to speak or not. But I think it would be helpful. I think part of the reason for this is that the client doesn't directly talk to the helper, for example, right? The reports are forwarded via the leader, so we have to do it via the extension. We can't do it via HTTP.
Good. That's what I thought. Okay. So the thing is, the DApp threat model does not include the leader or helper lying. And so it's already the case the leader and helper can totally mess up the results simply by like adding numbers to the reports. And so attempting to prevent Sybil attacks, like saying you're concerned that like that the leader will not adequately suppress Sybil attacks by checking Privacy Pass is like missing the forest for the trees.
Okay, thank you.
Watson Lad, Akamai, I guess I have a similar question, but a different take on it, which is my understanding of sort of the PPM threat model is that the client doesn't trust we trust the leader and the helper as people collecting the measurements and evaluating them. What we don't necessarily trust is the client doesn't necessarily trust the leader and the helper to preserve the client's privacy. And so in that threat model, it doesn't really make sense to shove the token in there versus use it in HTTP. And if you're changing that threat model, then I think you have to change a lot of other things as well.
I don't think the threat model is currently changed here. And so basically yes. So basically the leader and the client might trust the leader and the helper, and we don't necessarily trust the client. And however, the problem is this doesn't really solve, for example, the malicious client from launching sending a huge number of reports, and so that the report swarms the leader and the helper, and it basically then it potentially can cause the privacy breaching and also statistical poisoning.
Hi, I'm Tanya Verma from Cloudflare. I just wanted to mention that the problem about reusing tokens across tasks isn't just good for optimization, but we can use it across different tasks to track malicious behavior that would only be expressed over a period of time or across different tasks. So I'm thinking of a couple different examples, but I'll leave it that for now.
So the reusing of the the tokens across tasks is the main motivation is so that there won't be a flood number of requests on the privacy path infrastructure. So for like we explained here, basically this extension assumes that the client always prefetches a huge number of tokens. And so there can be quite a lot of tokens wasted because the client may not be submitting any of the reports. And so the motivation for reusing the tokens across tasks is so that, for example, basically the client don't have to allocate for maybe, for example, 10,000 tokens every day.
So I just wanted to take a step back and just remind people of what the proposal is. This is proposal for a working group draft that we would work on. And its goal is to mitigate Sybil attacks, which we want to do. And we don't intend to change the threat model. We would like that Sybil attacks are mitigated under the non-collusion assumptions that exist for DApp and Privacy Pass today. So in that spirit, I think this is a great starting point. This draft, I've read it. It might be the case that we can do the integration differently. In the past, we've looked at different extensions for DApp and decided that an explicit extension in band isn't actually necessary. I think this is debatable for this draft. I think there is something nice about having the binding of the token to the report. But I would love to see, I'd love to see more discussion on this. But I hope people recognize basically this is a problem that we want to enable deployments to solve, and Privacy Pass makes a lot of sense. Thanks.
Tim Gagan, ISRG. So in this scheme, the helper will extract the token out of a report extension and then validate it. So what I'd like to understand is where does the helper get the public key to verify the token against?
So this would be out of band. In this case, the helper would have to trust the issuer, and it also needs to contact the issuer for the public key. So the simplest is just to go to the issuer's well-known public directory and obtain the active key currently listed there.
Okay, so basically you would have one of the task parameters would be a URL from which the helper should fetch the current, or maybe a list of public keys with which to validate these tokens.
I think it would be it depends. It may or may not necessarily be one of the task configurations. So, for example, if the helper or leader has their own maybe static configuration, which issuers they want to trust, then those can be like hard coded.
I see. Okay, interesting. Thank you.
Thank you.
Thank you, Lin-Mao. We have anything else before we wrap the meeting? Thank you for joining us for PPM at IETF 117. We will see you next time. Yeah.